Hi, my name is Molly, and today we're going to be talking about geometric series. So first of all, what is a geometric series? And the geometric series can be defined by the series as it starts at n equals 1 and goes to infinity of ar to the n minus 1 is equal to a plus ar squared plus ar cubed plus ... And if the absolute value of r is greater than or equal to 1, the series will diverge. And for part B, if the absolute value of r is less than 1, the series will converge. And that formula for that will be the series as n starts at 1, goes to infinity, ar to the n minus 1 is equal to a all over 1 minus r for all absolute value of r's less than 1. And then for question 2, we're supposed to find the series. The series where I starts at 1 to infinity of 5 to the minus I. And this is the same thing as we're starting at I equals 1 to infinity of 1 over 5 to the I. And so if we wanted to write a few terms here, we'd write 1 over 5 to the 1, 1 over 5 to the 2, 1 over 5 to the 3, 1 over 5 to the 4, ... And so as you can see, changing here, it's changing by 1/5. And that's because 1 over 5 to the third is equal to 1 over 5 times 1 over 5 times 1 over 5. And 1 over 5 to the fourth is equal to 1 over 5 times 1 over 5 times 1 over 5 times 1 over 5, etc. And so this changing by 1 over 5 here, this is going to be the value of r. And so then we can use our equation, a all over 1 minus r equals s, to say a1, which is the first term. In our case, the first term is 1 over 5, all over 1 minus r. And we said r was 1 over 5. This value is equal to 1/4. That's the answer for that question. And then for part B, they wanted us to rewrite this equation, x over 2 minus x, as a geometric series. So this needs to become something like 1 over r. And so what we're going to do is pull out some terms. So we're going to pull out 1/2 x all over 2 over 2 minus x over 2 to get that. And we can also pull out an x. So that can be 1/2 x times 1 over 1 minus x over 2. So that there is our equation rewritten as a geometric series. In this case, where a is equal to 1/2 x and r is equal to x over 2. And so then to determine where it converges, you know that it'll be converging when the absolute value of r is less than 1. So r, we said, was x over 2 is less than 1. So that's 1/2 of it, and then x over 2 greater than -1. So then we solve these inequalities and we find x less than 2 and x greater than -2, which if we put those together, we would say that x must be in between 2 and -2 in order for this series to converge.